So we are going to use initial proposition 2, that is S proportional to theta, and we are going to prove it that this proportional sign can be replaced by an equal sign by multiplying the theta with r, or radius of circle. So for that we might need what we're going to need. So we are going to need an arc that is smaller or that can be bigger, which one sounds you to best, you can use that. So we are going to use the arc. Let's use a smaller one because that's what that is what written in your book. So let's call that arc RB. Oh, it might sound confusing, so I'm gonna change it to DB. DB from Polish. So DB. So let's use this theorem again. S is proportional to theta, and before we jump onto that part, we are gonna declare that the angle at the center, angle created by the arc dB at the center is theta, and the POB arc is a radian arc. That is, the arc PB is creating one radian angle at the center. As you know, 1 radian angle. So it is 1 radian angle. So let's use this theorem again. S is proportional to theta. S is the length of the arc, and theta is the centered angle. So for first we're gonna write dB, and divide it by PB. That is, we are taking a ratio of both these arcs, PB and DB, ratio of length of these two arcs, and now as they are proportional, we are gonna write the respective angles in a ratio form. So it should be theta and 1 radian. Theta and 1 radian. So since the arc PB is creating a 1 radian at the center, the length of this arc PB should be equals to r. As you know, the length of the arc PB will be equal to r because that arc is created, and because that arc is creating a 1 radian angle at the center. So we can write dB by r, because that is the length of the arc PB equals to theta by 1 radian. So let's assume that length of the arc dB is s. So we can write then s by r equals to theta by 1 radian. So if we take that r from the opposite side, we get s is equals to r theta by 1 radian, and as we know, we don't have to write 1 when in mathematics, so we can write s is equals to r theta. So as you are seeing right now, it's quite easy to prove that s is equals to r theta. So I hope you understood what I said. So next move on to the actual relation between radian and degree measurement, and for that we will need the previous value of 1 radian. That is, 1 radian equals to 2 by pi into 1 right angle. So